Good afternoon, everyone. In this video, I will continue the discussion with steps for the class design. I'll be specifically discussing about design optimization. So, a good way to design a system is to first get the logic correct. Okay. Say, for example, whatever the task like it has to do, first get a design which actually can perform exactly the operation the way you expect. Then you actually try to optimize it. Okay. Basically, like a premature concern with efficiency, okay, if you are too much concerned with that one, actually leads to inferior design. Okay, it will not be so efficient. It will be very difficult to manage. Okay, this does not mean like you completely ignore the optimization step. Okay, say for example, if something is really inefficient and you can pretty much, it is obviously clear there. Okay, optimize it. If not, then wait for the optimization until like you have the preliminary design ready. Okay, so basically like if it is pretty obvious, do it, but don't do something in a complicated and unnatural way just because you have certain I mean like you may think about like certain performance inefficiencies or something. Okay, so that's about like design optimization step is concerned. First have the basic design ready and then like you basically try to optimize. We already have discussed, and again like it comes into picture, often a small part of the code is actually responsible for most of the time or space cost. We have actually looked at the 20-80 percentage model during one of our earlier videos. Okay, and then like since it is like that one, it is better to focus at the optimization on the critical areas rather than spread effort evenly across all the methods. Okay, across all the operations. Okay, so then it will basically lead to very inefficient thing, and you cannot manage it anymore. So going back few steps. Okay, so the design model actually is built on top of this analysis model. We already got the analysis model during this sort of both system design and analysis class design. We are actually building on top of this analysis model. Okay, the analysis model captures the main logic of a system, while the design model is actually trying to add all these sort of development details, which will be really relevant when we really go into this sort of implementation. Okay, which is the next step, next stage in object-oriented development. Okay, we can actually optimize the inefficient but semantically correct analysis model to improve the performance. Okay, that's what we actually can do. Okay, however, as I have always been telling, like the optimization should be a little bit balanced. Okay, an optimized system is more obscure. Okay, so you are actually hiding most of the important things. Okay, and then like it is really lost in the jargon. Okay, and less likely to be reusable. You may not be able to reuse this sort of optimized models in other applications. Okay, so but anyhow, like we also have seen like, okay, so only if you basically take the analysis model and then keep extending in these design stages, then they both will be in sync. Okay, alternatively you can actually store them for a different purpose, but then like in the iterative steps, like you are actually adding all these optimization details, etc. Okay, that's why like we must basically be able to strike a balance between both efficiency and clarity. Okay, so efficiency in terms of reusability and then like the other aspects. Okay, so maintainability, etc. So there are several tasks for optimizing these sort of models. Okay, so in this class design stage. Okay, so first thing is like provide efficient access paths. What are all these things? We will discuss in the coming slides. Okay, so we have to basically provide efficient access paths. Okay, this basically deals with associations. We'll talk about it. And then like we have to rearrange the computation for greater efficiency. And then like we also have to save intermediate results to avoid recomputation. Okay, so these are some of the optimizations which you can actually introduce into this class model. So let us first look at that one. First look at adding redundant associations for efficient access. Whenever we were thinking in terms of say for example both domain analysis and application analysis, putting redundant associations was not at all desirable. Okay, it will not add any new information for you. Okay, so it was considered not so efficient during the analysis stage. Okay, which can be like both domain analysis and also the application analysis. But design is a different thing, completely a different focus at that particular problem. Okay, it has different motivations. Okay, and it focuses on the viability of the model for implementation. So this design is always thinking in terms of like how you got the analysis, how you will be actually implementing it. Okay, so now you will look at all the associations which were actually developed, okay, which were drawn during this sort of design stage, and we will try to have a reassessment. Say for example, can the associations be rearranged to optimize critical aspects of the system? Okay, if so, during the design stage, you should be actually doing that. Should new associations be added? Can existing associations be omitted? Okay, you can actually remove that. Okay, so basically, like you will be checking at all these things. Okay, in this stage, let us look at an example. In that example, like I will try to explain like what I really mean by say for example adding new associations and arranging them and etc. Okay, let's try to look at this example. Consider like, say for example, here is the sub part of the class diagram for that particular application. So there is a company actually employs several persons, okay, and each person has some skills, okay. So this is like one to many association here employs and many to many association here has skill. Okay, this is the basic class design which you have got, for example, from the analysis you have got. Okay, say for example, in this case it is domain analysis. From the domain analysis you got it. Okay, and now the point is like during the earlier stages of this design, okay, you have already identified the applications, and one you have already identified the operations. One of the operations is find skill. Company has a operation which is called find skill, because the goal is like we want to consider the design of a company's employee skill database. We want to basically consider this, okay, design of company employees skills database. Now basically the question is, okay, say for example this company or find skill, okay, this company has this find skill operation which actually returns a set of persons in the company with a given skill. So it basically returns a set of persons with the given skill. Now why I am putting this one is like, say for example, think we are trying to find out all the employees, okay, all the employees in that particular company who can actually speak German, for example. Okay, now if we really look at this one, so for example company dot find skills, okay, okay, so this method actually have to identify all the people who has the skill as German. That is the actual goal. Now assume like this company has 1,000 employees, okay, 1,000 persons are here, okay, one to many, so this company has 1,000 employees, and assume like each person has approximately 10 skills on average, for example. Okay, now if you want to find all the employees who can speak this German language, okay, very simply, like if you basically go by the simplest loop, okay, in this company dot find skills method of operation, okay, what you have to do, you have to traverse all the employees, okay, all the 1,000 employees, so which is like 1,000 times. Okay, so you basically have to call this one, and for each and every employee you are calling this has skill, okay, 10,000 times, so 10 times, because like each one has 10 skills on average. So that you just multiply them, so 1,000 by 10, so it basically has to traverse 10,000 times this has skills. And now if you think about the problem, like say for example only 5 employees actually speak German in that particular company, then the test to hit ratio is almost like 2,000, 1 is to 2,000. Okay, so that is pretty huge number. Okay, this will be like in terms of the design is concerned, say for example by the time like you came to this optimization step, okay, the method was perfect. Okay, so it was solving whatever you wanted to do, but now how to optimize this one, because like it is very inefficient. Eventually if you go to the implementation, it will be a very bad implementation. There can be several improvements for that one. Okay, one thing which actually helps us is the collections which we have already studied. Say for example even with the languages, I mean like with Java language, we can use say for example hash set. Okay, say for example like this person has skill, okay, this is approximately on average 10 skills. If you save them in some sort of unordered list, then you have to go through all the unordered list. Okay, that's how like this has skill has to basically go 10,000 times. But alternatively, if the hash skill you maintain a hashed set, okay, which we have already seen. With the hash, like you can actually invoke these skills in a constant time. Okay, so you don't need order of n. So automatically, like this rearrangement actually reduces the number of tests from 10,000 to 1,000. Okay, so that is one optimization which you can actually do. Got the point? So basically, like the company, you will have the persons hash skill is maintained as a hash share. So that means like the traverses will be only 1,000. Okay, that is one approach. Alternatively, you can actually prepare indexes. An index can actually improve access to frequently retrieved objects. Okay, so we will be using it in the cases where like the number of hits from a query is really low because few objects satisfy the test, the way like we have seen it. So how do you actually maintain this index? What it actually means? Let's go with see the same example. Say for example, now earlier you had this only employees association. Now you put a derived association. This speaks language. Okay, say for example, for each and every company, like for the person, you maintain another association which is speaks language. Okay, and it is a qualified association. So basically, like that particular language is the qualifier. Okay, we have seen the qualified associations when we were like, studying the class models. Okay, class diagrams actually. Okay, in the unit one. Okay, so then it is pretty easy for you. I mean, like you don't need all these sort of thousands of things. Like when you basically want to get all the persons who can actually speak a particular language, say for example German, you can get that one pretty easily, very simple, because like you have maintained this derived association and you have maintained this derived attribute. Okay, and then like you can actually index that. Okay, but indexes actually come at a certain cost. They require additional memory. Okay, because like earlier you were storing only these objects, now you have to also store that list, so that index as well. And these indexes must be regularly updated whenever the base associations are updated. Okay, so we should basically have to consider that these are the additional costs. Okay, and again, like we have to find a balance when to create indexes and when not to. Okay, so trying to put all the things together. So what about adding the redundant associations for the efficient access? So what we will be doing is what you should be doing. Okay, yeah, and during this design stage is examine each and every operation and see what associations it must travel to basically obtain its information. Okay, that's what you will be doing. And next, for each and every operation, note the following things. Find the frequency of access. So how often like you are actually asking that question. And then like you basically get the fan out. Fan out actually shows like represents the number of accesses on the last class in the path. So how many accesses you are actually doing. In the earlier case, like for that has skill, like you are doing that fan out 10 times. So now you basically have to multiply the individual fan outs to basically obtain the fan out of the entire path. That's how like we were actually getting the 10,000 there. 1,000 multiplied by 10. You basically get the fan out. Then you actually have to deal with the selectivity. What is the fraction of hits on the final class? Okay. If the traversal rejects most of the objects, then a simple nested loop may be inefficient. The way like we have actually seen in the earlier example. Okay. Then basically like we should provide the indexes for frequent operations with a low hit ratio. And that's what exactly the example in which I was actually showing that. Hope it is clear. Now let us move to the next step in this sort of optimization. So rearranging execution order for efficiency. Once we have actually adjusted the structure of the class model to basically optimize these frequent traversals, the next thing we should focus is at the optimization of the algorithm itself. Okay, so we already have seen like the operations, we are actually trying to put the algorithms as well. Okay, as part of this class design. So to optimize the algorithm, so we may have to eliminate dead paths as early as possible. Okay, and then like we also want to narrow the search as soon as possible. Sometimes we may have to invert the execution order of a loop. Okay, so all these things we actually have to do to basically optimize these algorithms. Okay, so this is not just for object oriented design, like it is it's a good things. These are good steps for even for any other algorithm. Okay, which you should have studied in your data structures. Okay, all the algorithmic courses. Let me give you an example. Let us take the earlier example itself and then like let us try to extend. Suppose like you want to develop an application that must find all the employees who speak both Japanese and also German. Okay, Now think about the case, like suppose there are 5 employees who actually speak German, and say for example 100 employees who actually speak Japanese. Now here you want to find employees who can speak both the languages. Now think about this case where like it is not so optimized implementation of the algorithm. Say for example, first you try to find all the employees who can speak Japanese. Then from there, like you actually filter the people who can speak German. That would be a bad thing because like first you will get 100, and then like from there, like you will basically filter 5 more. Alternatively, the point is like you basically just get these German speaking people. Okay, the implementation is actually reverse. The execution order is reverse. Okay, you just get like all the people who actually speak German first, which actually comes 5, and matching them whether they speak Japanese is pretty easy for you. Okay, you don't have to iterate so often into those loops. That's one way of optimizing the thing. Okay, so you have to look for this sort of optimization of the algorithms itself. Okay, first thing is like you actually optimize the complete design itself, the class design itself. Okay, by adding new associations, etc. Then you basically try to optimize it. But when we looked at, say for example, like these derived objects, okay, so derived attributes and all the things. Okay, so for further optimization, you have to actually save these derived values to avoid recomputation, because derived attributes means like you always have to recompute them. Okay, for doing that one, sometimes it may be helpful to define new classes as well, and you may actually have to cache these derived attributes and avoid recomputation. Okay, so but the catch here is we have to update this cache regularly. Okay, if any of the objects on which it actually depends are changed. Say for example, there are certain attributes are there, okay, in certain classes, and you have derived attributes, okay, so which you have calculated, and then like you are storing it in some place like something like cache, okay, in a different class, for example, or in the same class. Okay, it doesn't matter. But the point is like every time like if these attributes actually change, the derived attribute should also change. So that's a little bit tricky problem. There are several ways you can handle these updates. One approach is like explicit update. So in this case, like as a designer, you can actually insert the code in such a way that whenever there is an update in this sort of operation of the source attributes itself, in that operation itself, you explicitly update the derived attribute as well. That you can actually do. So you can actually design, and then like you can adapt your design or optimize your design to basically take care of that as well. Okay, during this class design stage. There are other alternatives as well. Say for example, periodic recomputation. So the thing is like, say for example, applications often update values in bunches. So basically what you can do is like at certain times, like we can recompute all the derived attributes periodically instead of after every source change. But the problem is like if these things are basically change pretty often, you have to wait for the next update. Okay, when you are actually calculating all these bunch values. Okay, when you are recomputing all these derived attributes. So some that may leads to some synchronization issues sometimes. Okay, so you have to find a balance between the two. There is another approach which is called active values. An active value is a value that is automatically kept consistent with the source value. There will be like special registration mechanisms using which like you actually register your dependency between these source attributes and the derived attributes. So once you have this sort of registration mechanism is actually taking care, okay, so you basically register it, okay, this dependency is actually registered. This registration mechanism actually regularly monitors the values of the source attributes, okay, and updates the values whenever there is change in this sort of source values. Okay, so the derived values are regularly updated in that order. So there are several approaches for that one, but the main optimization what we are looking at is like somehow like these derived values you have calculated once, you want to store them so that like you don't have to recompute every time you want to use that. Okay, and these are some of the optimization mechanisms which you should be actually introducing into your class design. Okay, in this class design steps, like this sort of design optimization is also a very important step. So as far as the references are concerned, we are still in chapter 15 of object-oriented modeling and design with UML, Michael Blaha and James from Bob. Thank you very much for your attention.